Okay, let's go through the chi-square test. It's a very popular test, but I think it's also a test which is widely misunderstood, right? Now, before we start, as usual, let's go through some basic terminology and definition. Now, when we talk about populations, there are two very distinct populations. One is the epidemiological population and the other is a statistical population. Now, epidemiological populations are not enumerated, right? There is no sampling frame for it. A good example is the number of people in any country. Like for example, in Malaysia, we know the exact count of citizens of the country because we have our IC, but we do not know the number of foreigners or permanent residents and things like that, or people with expired visas. So that is an example of an epidemiological population, right? Now, statistical population, on the other hand, is a fully enumerated population. That means we know everybody in the population. So typically the students in a school will be a statistical population, whereas the people residing in a country will be an epidemiological population. So when we talk of conventional statistics, right, we are only referring to statistical populations. Now we are not referring to epidemiological population. So a lot of the time statistical principles are misused in epidemiological population, right? So now let's pretend that this is a school in USJ, right? Now we want to know the average height of students. There are three ways to go about it. One is we go and measure every student in the school and get a mean height. Now that would be called a parameter. When you have taken every measurement in the population, that is known as a parameter. It is a descriptive statistics, and there's no uncertainty at all because everybody has been counted, right? Now suppose we don't we have no time to measure every single student, so we go to the nearest class, which is the form 3 class, and then we measure them, right? Now we are going to have a bit of difficulty describing it because we cannot call that form 3 group a random sample of the entire school, right? So it is not really a sample. So when it's not the population, nor is it a sample, so it becomes difficult to decide whether it's a parameter or statistic. Nonetheless, it is still descriptive statistics, right? There is no uncertainty here because you have measured everybody in form 3, but you can't apply it to the whole school because it's not a random sample. Now, the random sampling that we typically refer to is when you randomly sample students from the entire school, and from that random sample you calculate a statistic for the height of the student. So that is known as inferential statistics because that you can apply it back to the whole school, but with an uncertainty measure like confidence interval or p-value. Now I've got other videos for confidence intervals and p-values, and I'm not going to go through that. Right. So this is something that you can read through. I'm not going to go through it now. Now, when people talk of chi-square test, very often they probably don't realize that there is more than one type of chi-square test. There are actually three types of chi-square tests, right, which are in common use. One is the chi-square test of independence or association. The other one is the chi-square test of homogeneity, and the third one is the chi-square test of independence of goodness of fit, right? So the most important one that we tend to use in a routine medical research is, or rather we tend to misuse in routine medical research, is the chi-square test of independence or association. The reason why we misuse it and confuse it is because all these three tests have got very similar setup, that is the 2 by 2 contingency table, right? So basically a chi-square test of independence takes you are taking them from one population, but you are measuring two different variables. Like you go to a population of Malays, and then you ask them whether they are smokers and heart disease, right? So you only have one population, but you're asking them two questions each. So that is known as the chi-square test of independence. What you really want to see is whether if you know the level of smoking, whether you can predict heart disease, right? And here, as I go through, you will see something called degree of freedom. You must pay attention to it, because different chi-square tests have got different methods of degree of freedom. So this is what typical chi-square test table looks like. You have got whether population, either what do you call it, smokers or non-smokers, right? And what do you call it, race. So you have got their smoking status and race. So but they're all one population, that is they are Malaysian. Now chi-square test of homogeneity is slightly different. Here you have two populations, right? So you can say that you can take Malay and Chinese, you can call them one population each. Or if you want to take them as Malaysian, then you can say Malaysian and let's say Thai people, right? But you ask them one question, and basically what you want to see is you ask them whether they are smokers or not smokers. So basically what you want to see is whether the population of smokers in Malaysia and Thailand are the same or not. Okay, so that is the test of homogeneity. But when you look at the table again, you will find that the table looks very similar, right? You have got two populations. Like here I have chosen the population to be one Malay, one Chinese, and the smoking status either smoker or occasional smoker. So you will find that the table looks the same. So it's very easy to get confused, but you cannot afford to get confused because it's asking a different question altogether, right? The next one is goodness of fit test, right? Chi-square goodness of fit. Now here again is a different type of question. Here you have got a preset distribution. That means let's say you have 20% in the population of are smokers and 80% not smokers. That is your prefixed distribution. So you want to know whether the population that you have sampled, whether it fits that distribution or not, right? And here you can see the degree of freedom looks slightly different, okay? But when you look at the 2 by 2 chart, it can look very similar. So it's very easy to get confused with these three tests of chi-square test, right? So what question does the chi-square test of association answers? It answers the question whether we can reject the null hypothesis of no relationship at any particular level, let's say 0.05, right? Or we have insufficient evidence to reject the null hypothesis of no relationship. It is very similar to the t-test, which allows you to reject the null hypothesis of equal means, right? So there's a lot of similarity between the chi-square test and the t-test. Now, another concept that you've got to understand is the degree of freedom. This can be a very complex concept to understand. So what I'm going to do is just to give you a very simple overview of it, right? Let's see. Right. Suppose I have 3 columns, right? And I don't say anything to you. So you can go and fill up each column with any number you like. So your degree of freedom is 3, right? Because each column you can fill it up with whatever number you like. Now let's say I give you the same 3 columns, but I tell you that the mean of all 3 must be 4. Okay. So the first column you can fill in whatever you like. The second column you can fill in whatever you like, but the third column you cannot, because now you have to make sure that whatever number you put in, the total has a mean of 4. So this is a very simple explanation as to what the degree of freedom means, right? So here you will have only 2 degrees of freedom instead of 3 degrees of freedom. So different types of uh, tests have got different calculations for degree of freedom, and this can be very confusing, because as you can see here, you have got a capital N, which is all data, a small n, which is sample, K, which is categories, R, which is row, C, which is column, and you must make sure that they're actually meaning what they say that they mean, right? If you look through all these kind of tables frequently enough, you'll find that sometimes they make mistakes. So you always have to understand for that particular statistic that you are calculating, what do they mean by degree of freedom? Okay, so now I want to highlight a particular principle which I think I've done before with the t-test. And that fact is, this chi-square test is very often misunderstood, right, and misused. Now, first of all, in order to do a chi-square test, right, it must be a random sample, right? And most medical research are not random sample. Number two, you must use frequency, not percentages or proportions, right? The absolute raw numbers you have to use. Number three, chi-square test, just like the t-test, the chi-square statistic is very dependent on the sample size. So you can make a chi-square test statistically significant or not just by increasing or decreasing the sample size, and this we have seen with the t-test as well. So whenever you have a value in which the significance of it can be increased or decreased by just manipulating the sample size, then you have got to be very careful before making any comment of it on it. You should only comment on the difference in the means or difference in the proportions. So I've given you an example here. Now all this have got exactly the same difference in proportion, right? But by simply increasing the sample sizes proportionally or decreasing it proportionally, I've managed to make it statistically significant or statistically not significant, right? So when it comes to medicine, please don't bother to use the chi-square test of independence or association. It is a useless test. What you need to know, what you need to inform us is whether or not what the difference in means or difference in proportion is. This is basically your effect size. If you do a chi-square test and it's not statistically significant, that simply means that your sample size is not big enough for the effect size that you get for your study, right? So you just got to increase your sample size. Okay, thank you very much. Now, if there are any errors in there, do let me know. I'll put the corrections up in my YouTube or Facebook page. Thanks.